evening. I am RJ Boy Agisando, and together with my partner Jan Paul Alojado, we're going to present our activity about multiple regression using Excel. So multiple regression simply determines how much of each one is needed. Thus, the form of the equation is the goal is to find best m values for AI given the m functions of fix and data that has a value of yi that is equals to y and xi that is equals to 1. So in Excel, you put the x values in column and create additional columns with each column being a function evaluated for the x value in that row. For example, use here is to find the constant in a reaction rate formula. In the formula is the rate is equals to Kp raised to Na times P raised to Mb. The goal in this is to find the values of K, N, and M that will give the best fit of the rate for various partial pressures of substances A and B. Again, this form is not linear since in multiple regression, it is required to use linear equation. So we're just gonna take the logarithm in both sides of this equation, and we will have this formula. Ln of rate is equals to ln of K plus n ln of PA plus m ln of PB. That follows the equation that follows y is equals to A plus bx1 plus cx2. So to do this, first we put the values of the partial pressures in both substances. In this, column A and B are the partial pressures of the two chemicals, while the column C is the measured rate. To get the values of the column D, E, and F, we're just gonna take the logarithm of columns A, B, and C respectively. After that, we will proceed with parameter estimation by choosing data or data analysis and then choosing regression. But it must take into account that sometimes the data analysis is not found under the data command of your Excel. So if not, you just go option and add-ins command. After that, enter the values of your rate to your y range and enter your logarithm from ln of a to ln of rate to your x range. This will show the best line that will represent your rate logarithm depending linearly upon your logarithm in both partial pressures of your substances. Here you have different options. You're just gonna choose residuals, residual plots, and line fit plots because these are the best option for evaluating the results. You can place the results on another sheet in the same workbook or in the same sheet by specifying a location. So at this point, the correlation is complete. It is not though because the data were transformed to make the parameter estimation problem linear. Thus, the statistics are in terms of the transform problem. It is always a good idea to calculate the curve fit using the original variables. And now, we already have our parameters from our regression. And then our values for A is 1.9803 and our B is 0.9801. And for our C, we have 0.1894. And for our K, we have 7.101. And now, our rate formula is 7.101 PA that is raised to 0.9801 times PB that is raised to 0.1898. And next, we were having our nonlinear regression using Excel. So nonlinear regression is a curve fit in which the unknown parameters enter into the problem in a nonlinear way. Nonlinear regression is much more difficult in our computer, so it is best to always try to manipulate your model into a form that is linear. Sometimes that is not possible, and the nonlinear regression must be used. You need to be aware though that the method described here do not always work. Nonlinear regression uses techniques borrowed from the field of optimization, and it's difficult to construct a method that works every single time for every problem. So for this example, we were going to use our same problem in our linear regression. And here we have the same values for our PA, for PB, and the rate. But first we need to calculate our column D, which is the rate. So in column D, we were going to calculate the value of rate using the parameters in our C column and the data in our column A and B, and the formula, which is the rate equals to K, P raised to N, P raised to M. So first, we're going to calculate our rate. So that is our value for K times our value for PA raised to N times value of our PB raised to M. And then we were going to solve for our residual values by subtracting our values from C and now we already have our values for our residual column. Then we're going to solve for our residual squared by only squaring the values in our residual column. And then the sum of the column F divided by the number of entries, we're going to obtain the sum of square. So this is our target values for our K and M using the nonlinear regression in Excel. But what will happen if we are not given of the values of our K and M? So what if we have a values of 1 in our K and M? The goal is to minimize the values of our sum of square by choosing the values of our K and M. To do that, choose tools and then solver. You might have to add it to the Excel program if that was not done when the program was installed. File, and then options, go to add-ins, and click Analysis Toolpath and then go. After that, you will have your solver command under your data. Then click solver. And then for set objective, you choose your values of sum of square. And then choose mean and by changing variable cell. Our changing variable cell is our K and M values. And then click solve. And there you have it, our values for K and M. And we will going to insert our values that we have solved using our nonlinear regression. Then we're going to put our values in our formula that we have solved using our nonlinear regression. And now, we already have our best correlation in terms of multiple linear regression and multiple nonlinear regression. These numbers are slightly different between the two. So multiple regression and nonlinear regression obtain the solution by minimizing two different objective functions. So that would be all. Thank you for listening.